morning, Algebra 2. This is Semester 2, Unit 1 of the APEX Note-Taking Guides. We are going to be talking about rational expressions in this chapter, and we'll explain in the next few sections what a rational expression is. The big thing here is you guys have to be able to factor. If you cannot factor, you are really going to struggle with this because the majority of this chapter is factoring. So let's start with lesson 1.1. So this is proportions. Many of you have used proportions before and seen proportions before, so we're not going to go through super slow. We're going to progress pretty quickly, and then we'll answer questions if you have any when you get into class. So proportions. So a ratio is a comparison of two numbers written as a fraction. So you guys have probably seen ratios written like this, or A to B, okay? But it can also be written as a fraction, okay? And remember that a fraction is just a division problem, okay? So we also have a rational expression. I didn't make this line very big, but that's okay. So a rational expression is a comparison of two polynomials that is written as a fraction. Okay, so in other words, we still have a ratio, but in this case, there's polynomials in the ratio. So remember, this is a monomial and this is a binomial. Now, it's really important to remember that anytime you have a plus or minus sign here, okay, that means that it is a single number. Okay? So we can't ever break that apart except for by factoring. Okay, so don't try and cancel things, right? Like if I saw 3 over 3, I would say, oh, that's 1. Well, here, oh, look, there's an x over an x, okay? But this isn't an x, this is an x plus 1. Okay, so that is going to be really important as we progress through this, that you guys remember that that is a single number. Okay, so a proportion then is an equation that shows two ratios or rational expressions are equal. So here, we have two ratios that are equal, okay, or two rational expressions that are equal. Okay, so we're just saying that 1/3 is the same thing as 2/6. So it's essentially equivalent fractions. Okay, so this is the same thing. Remember, this is just a number and this is just a number. So whatever number this is equivalent to 1, and whatever number this is equivalent to 2. So, for all I know, this could be, x could be 4, right? And then it doesn't work here, but, right, so this number would be 8 because that would be equivalent to 1/2. So, the goal is you would have to solve it and find out what x is at some point. We're not going to we are going to do that here shortly, but we are going to do it later using more complicated rational expressions. Okay? So our method for solving proportions is actually to cross multiply, and I'm going to show you why we cross multiply, because there is a reason for it. Okay, so when you cross multiply two equal ratios, the cross products are equal. Okay? So let's this problem right here. So it's showing us that this times this equals this times this. But let's see why. So I'm just going to write it up here. So 1/3 equals 2 over 6. Okay, so when I'm solving, I always want to get rid of the denominators first, right? If I was just to show to the algebra. That's all it is. Six. Okay, so let's take a look at how this works when we're solving for x's. Okay, so we're going to cross multiply, and then we're going to solve for the variable and simplify. Okay, so the first thing is I'm going to cross multiply. So I'm going to take that, right? 1 times 6 equals, and I'm going to cross multiply, 3 times x, okay? And I get 6 equals 3x. Okay? So now I'm going to go on ahead and simplify by dividing both sides by 3, and I get 2 equals x. Okay? So some people like to think of these as kind of like butterfly wings. Okay, so that butterfly wing, and then there's their, little head with their antenna. Okay, so if you want, you can call it the butterfly method, but it's really called cross multiplication, but it's really just algebra. Okay, so let's go on ahead and let's solve this one. So 10 times 9 is 90, equals x times 18, which is 18 times x. Okay, so now I'm going to divide both sides by 18, and 90 divided by 18 is 5. So 5 equals x, or I could write it as x equals 5. Okay, so that's my symmetrical property. Okay, so I can write it this way, or I can flip it and write it the other way. Okay. All right, so let's take a look at some more examples, and these are going to, get a little more difficult. As these get more difficult, you're going to think that you can do them in your head, but you need to remember that sometimes you'll forget some steps, so it's important that you write these out. Okay, so I'm just going to do 3 times 20. Okay, so 20 times 3 is 60. Okay, equals 8x. Divide both sides by 8, and I get x equals 7.5. Okay. All right, so now I'm going to go ahead and do the next one. So 3 times x equals 6 times 4. Okay, so 3x equals 24. Divide both sides by 3, and I get x equals 8. How can I find out if this is the correct answer? Well, I can plug it in. So 8 over 6, okay, does it reduce to this fraction, to 4 over 3? So if I divide this by 2, whatever I do to the numerator, I have to do to the denominator, then I get 4 over 3. So yes, it is equivalent fractions. Okay. So let's take a look at the next one, 2 times 12. So 2 times 12 equals 7 times x. So 24 equals 7x. And divide by 7, and you get 3.4. All right, so this one is where sure that you are using your, that you're writing stuff out. Okay, so here, 10 times 9, that's not too bad, right? We could probably do that in our head. But here's where the error occurs. 3 times x plus 1. I often see this done, okay? And you guys are doing it super fast, and so you're saying, oh, that's 3x plus 1. But remember that that 3 has to be distributed to both terms. And like I said, this is the biggest mistake I see on these, forgetting to distribute those values to both terms. Okay, so this would be 90 equals 3x plus 3. Now we're going to subtract 3 from both sides. We get 87 equals 3x, and divide by 3, and we get x equals 29. Okay. All right, let's take a look at the next one. So 7 times 11 is 77. Like I said, that one's not too bad because it's just numbers. Binomials. I'll remind you that one single number, right, once we plug it, and number to distribute. Now in this case, this is a 1, so it's just going to be 77 equals 2x minus 3. So I'm going to add 3 to both, and I get 80 equals 40. And once again, if I plug that back in, I'll see that that's 7 over 80 minus 3, which is 77, and that reduces to 1 over 11. Okay. So remember, this is just a number. In this case, it's 77. All right, so here we have where we have more binomials. So we're going to have 4 times x plus 4 equals 8 times x plus 2. And once again, remember, you have to distribute. So that's going to be 4x plus 16 equals 8x plus 16. So now I'm going to subtract 16 from both sides, okay, and I'm going to get 4x equals 8x. Right? So now I'm going to subtract 4x from both sides. So I'm going to get 0 equals 4x. Divide both sides by 4 and I get x equals 0. And so remember, just because you get a 0 over here doesn't mean anything. And what happens is if you get one side that does not equal the other, okay? But in this case, we can still combine this 4x with this 8x because they're like terms. Okay? All right, so let's go ahead and do the next one. So 2 times 3x minus 1 equals 1 times x plus 2. So now I need to distribute, so I get 6x minus 2 equals x plus 2. Okay, I'm going to go on ahead and subtract 6 from both sides. Not 6, I'm going to subtract x from both sides. Okay, and I get 5x minus 2 equals 2. Add 2 to both sides, and I get 5x equals 4. So I'm going to divide both sides by 5. And remember, we are in high school. It's okay to have fractions and decimals. Okay? For the most part, we want you to leave it in the most accurate form, which is going to be fraction form. Okay? But if I don't specify, or I specify round to a decimal place, then it's okay to change it. Okay, but pay attention to those. Okay, so here we're going to have 1 times 6, which is 6, equals x times x plus 1. Okay, so now I'm going to have 6 equals x squared plus x. Oh, look, this has an x squared in it. It has an x and it has a constant. So it's looking like it's going to be a trinomial that I'm going to have to factor. So I'm going to subtract 6 from both sides, and I get x squared plus x minus 6. So now I need to find my factors of 6, negative 6. That would be 1 and negative 6, negative 1 and 6, 2 and negative 3, or negative 2 and 3. And I need the pair that adds to this positive x. So that's going to be this pair right here. So I get x minus 2, and I get x plus 3. But I have to double check and make sure that both of these work. So I'm going to go on ahead and finish solving it. So when I did this, it equals 0. So now I'm going to set each of these equal to 0 and solve. So I'm going to add 2 to both sides, and I get x equals 2. So 2 is one of the values that x can equal. And x plus 3 equals 0. Subtract 3 from both sides, and I get x equals negative 3. Okay, so those are my two values, but I need to plug them back in and check. So here, if I put 1 over 2 equals 2 plus 1, which is 3 over 6, okay, does that make sense? So I had to multiply 1 times 3, and 2 to 6 is times 3, so that checks out. So let's try it with negative 3. So 1 over negative 3 equals negative 3 plus 1 is negative 2 over 6. Okay? So here, to get from 1 to negative 2, I had to multiply times a negative 2. Negative 3 times negative 2 is positive 6. And remember, really, it doesn't matter where that negative sign goes on the fraction. It just means the whole fraction's negative. Okay, but in this case, it was easy to look at and say 1 times negative 2 is negative 2, and negative 3 times negative 2 is positive 6. Okay, so both of these answers work. So x could be either one of those. Okay. You are going to have some word problems that are going to deal with proportions. Okay, so in this one it says 9 inches wide and 12 inches tall. You want to reduce its size to 8 inches wide. How tall should the reduced picture be? So once again, we're just going to use ratios, which are the same thing as equivalent fractions. Okay, so let's draw a picture. So we have a picture that is 9 inches wide and 12 inches tall. I want to make this picture smaller, so it's only 8 inches wide, and I need to know how tall it's going to be. Okay, so now I'm going to set up a ratio. And when I set up my ratio, I want to make sure that I use the same parts. Okay, so 9 is my width, so under it I'm going to use 8. Right? And then the same thing, so 12 is my height, and x is my height. Okay? And notice that 9 and 12 are both from the big picture, so they're both on top. 8 and x are both from the little picture, so they're both on the bottom. Now let's go on ahead and solve this. So when I solve it, I get 9x equals 12 times 8, which is 96. And I'm going to divide both sides by 9, so I get x equals approximately 10.7 inches. Okay? But let's go on ahead and set this up a different way, okay? Because this is not the only way you can set it up. So if I want to use this picture first, I can say, well, 9 wide to 12 tall equals, so if I used wide on top, I need to use wide on top and tall on the bottom. So the important thing to remember is to make sure that, you know, if I decided to use my big picture on the top, it has to be in the same place on the fractions. Okay, and this was my little picture. Here, it was the width was on the top and the height was on the bottom. I could do the height on the top, okay, and the width on the bottom if I want. Okay, these are all going to give me the same answer. Okay, but you have to make sure that whatever is on the top of the fraction, whatever is on the bottom of the fraction, match. So once again, this one, 9 and 12, were both the big picture, and these two were both the little pictures. Okay. This fraction was the height, so that was tall, and this was the width. But then in this one, I said, well, I'm going to do the big picture, and I'm going to do the little picture. Okay. But notice these were both the width, okay, and these were both the height. Okay. So you can set up your proportions in a different way. Okay. You just have to be able to know that things match. Okay. And then it says write the answer in a complete sentence. So the height of the reduced picture, and I'm writing this because it says write the answer in a complete sentence, okay, is 10.7 inches. Okay. And you could put about or approximately if you want it. Right? Okay. You could write, you know, the reduced picture should be about 10.7 inches tall, okay? But you want to make sure that you are, you know, making it so that people know what you're talking about in the answer. And this gets important when you start getting into the higher math levels and start practicing for AP tests where you have to write things out. All right, let's do one more word. So this one right here. So we have a recipe and it calls for 5 cups of flour. So there's my 5 cups of flour. Right? And it calls for 3 cups of sugar. 3 cups of sugar. Okay. I want to make the recipe with 3.5 cups of flour. So 1, 2, 3.5 cups of flour. Okay. So how much sugar do I need? Okay. All right, so now we're going to set this up, and I'm just going to use this one. So 5 over 3 equals to this one, 4 over x. Oh, it's not 4, it's 3.5. Okay. 3.5 over x. And now I'm going to do my cross multiplication, so I get 5x equals 3 times 3.5. So 5x equals 10.5. Divide both sides by 5, and I get x is about 2.1. Okay. Now it says write it in a complete sentence. Okay. So I will need about 2.1 cups of sugar for my reduced recipe. Right. So I'm making less. I don't want to, you know, maybe I only have 3.5 cups of flour at home, and so I have to adjust the recipe, which I do that all the time. I bake a lot, and sometimes I just don't have enough of something, or sometimes I want, you know, 2 or 3 times more of it. You know, if I'm baking sugar cookies, my husband and my kids eat them like crazy, so I might bake, you know, 3 batches instead of just 1. Okay, so I always have to adjust whatever my recipe is. And it could be, tablespoons, it could be teaspoons, it could be, pounds sometimes if I'm weighing stuff, or ounces. So you have to really know how to do this, especially like in the kitchen. So anyways, these are all proportions. Make sure you know how to do these because these are going to carry through. And it's really important that you understand what they mean and how to do them. Have a great day, and I will see you guys next time.